So, good morning. Today we are going to learn the theory of automata and basically the finite automata part. Okay. So, a finite automata in general it is denoted by a five tuple system. Five tuple system. Okay. What are the five tuples? The first one is capital Q, then sigma, small delta, Q0 and F. Okay. What is capital Q? Capital Q denotes the whole number of states in a finite automata. As we know, any machine have different states, and these states are denoted as a set, and the set is named as capital Q. So capital Q is the set of states, and the condition is it should be finite. So any machine should have a finite number of steps. The number of steps is not infinite, and obviously there is at least one state. A machine there is only at least one state. So obviously it is non-empty. So a machine should be finite and non-empty. Second case is that second case is that the symbol sigma, okay, and the symbol sigma it is also a set, and the elements of this set is known as the inputs. So the number of inputs is finite. Okay, there is not any such case that the number of input is infinite, and it is also non-empty. What is delta? So delta is the transition function. Here transition function means that the machine, when the machine is running, it can move from one state to another state. Okay, and the move of states depends on two factors. First of all, first factor is that the present state of the machine, and in that state what the input that machine got. So using these two parameters, the machine decides what will be the next state. So delta is the transition function. Delta is the function which is also known as the transition function, which maps Q into sigma. That means the state and the input. The combination of these will decide the next state. So into Q. This function is describes the change of states during the transition. This mapping is usually presented by transition table or transition diagram. Okay. Another thing is that Q0. Q0 belongs to Q. What is Q0? So Q0 is the initial state. Okay. The machine could have multiple states, and one of the state is the Q0 is the initial. F is the set of final states. Okay. Is the subset of Q. Subset of Q means there could possible that the final state is number of many number of final states. In a machine, there could be one or more number of final states. So final state is the subset of Q. Okay. It is assumed that here there may be more than one final state. Okay. Here is the transition system is given, and it is delta. Okay. So what is it is delta? Here delta is defined as a transition diagram. Sometimes it could be given as a transition table, as a table. Here the delta is given as a diagram. Okay. From that diagram we can see that, so, first of all, what this arrow signifies, this arrow and this arrow, this arrow signifies that Q0 and Q1 are the initial states. So a single arrow pointing towards a state, that means that this is the initial state. Here in Q3 we can see that there is two circle. Okay. So it defines that Q3 is the final state. Okay. And whatever there is an edge, there is combination of 0 and 1, which signifies the first symbol signifies the input and second symbol signifies the output. So in that case, if there is a state transition from Q0 to Q1, it will happen if the input is 0, and in that way, during the transition process, it generates a output 1. Okay? So in that way, the transition diagram is defined. So what is the question? There is also a transition diagram is defined. We have to determine the initial states and the final states. So obviously, as we get the Q0 and Q1 is the initial state and Q3 is the final states. Now we have to decide the acceptability of two string. Okay, there is two string given 101011 and 111010. Okay, we have to decide the acceptability of these strings. So as you can see here, the initial state are Q0 and Q1. That is, if the arrow pointing towards a single arrow, that is the Q0 and Q1, the initial states, and there is two circle with state Q3. So Q3 is the one only final states, namely Q3. Now, path value of Q0, Q0, Q2, Q3. Okay, so Q0, Q0, Q2, Q3. In that way. Okay, first input 1, second input is 1, next 0, next 1011. So this is the as Q3 the final state 10111011 is the accepted by the transition system. But the second string is not accepted. Okay. Now, how could we decide that one string is accepted and another is not accepted? If using a string from the initial state, we can reach the final state. Then the string is accepted, otherwise it is not accepted. So in that way, we can decide that 101011 is accepted, but 111010, the second string, is not accepted because the transition system has there is no path value with using this string. Okay. So what is the acceptability of a string by finite automata? So there is a machine given Q sigma delta Q0F. We have already defined the definition of this machine. So if there is a machine with these parameters and X is a string, X is a string, then what is the acceptability of the string? The acceptability is that by using this X, that is the string from Q0. What is Q0? Q0 means the initial state. Okay. So from the initial state and using this string, if we reach some state Q, which is the final state, then we can decide that it is the acceptability of a string. Okay. For some Q belongs to F means what is F? F is the set of final states and Q is one of them. So Q is one final state. And if we reach Q using the string from initial state, then it is basically the acceptability. As you know, here we already described that some string is only accepted if we using this string from initial state we can reach the final state. Okay, so this is the acceptability of a string. Here is an example. Okay, consider a finite state machine whose transition diagram delta. So this is delta. Okay, so this is delta, and here we can see that the transition system is defined by a table. In the previous example, the transition system is defined by transition diagram. Here, transition system is defined by the transition table. And from the table, we can see that number of states is 4, that is Q0, Q1, Q2, Q3. Here, initial state will be Q0 and final state was also Q0. So, Q0 is the initial state as well as final state. And using the two different input 0 and 1, we can get the different states of the machine. Okay. Now, we have to give the entire sequence of states using the string, that is a string given 110101. Okay. So what is the solution? The transition system will be gone through the states, and the initial state is Q0. Here, as we know, the Q0 is the initial state. And using the string x, what is the value of x here? X is 110101. So this is the value of x, that is the string. The first character of the string is 1. So from the initial state, the first character takes as an input, and we will go through the next state. Okay. So the state is Q0 and 1 is the character taken as an input. So from the table we can see that if there is state Q0 and input 1 is given, the next state will be Q1. Okay. So next state becomes Q1, comma, the remaining character of x, that is 10101. Now we read the second character. Okay. That is second 1. From the table we can see that if there is state Q1, present state Q1, and input 1 is given, the next state will be Q0. So next state becomes Q0, and the remaining inputs are 0101. Okay. In the same way, we can see that here delta q1 comma 1, that is the last character. There is only one character left. So q1 comma 1. From the table we can see that q1 state and the input 1 is given. The next state will be q0. So q0 comma, there is no character left, so null. So the machine stops at q0. And here we can see that q0 is the final state. So at the end, the machine reached the q0, and it will be the as it is the final state. So the input string 110101 is accepted by the given machine. So here is the sequence from Q1 using the string x, which value is 110101. We reach the final state. And in that case, the arrow pointing towards a character defines the current input symbol is processed by the machine. Okay. For, for that case, this symbol is used. Okay. Okay, now we go through a new example of non-deterministic finite automata. So, a non-deterministic, why the name is called so? Because the machine cannot define the next state in a specific way. Because here in this case, for example, if the machine is state q0 and the input is 0 is given, what will be the next state? From the table we can see that using 0, the next state may be q0. So there is a self loop of 0. So the next state may be q0 or maybe q1. Okay. Similarly, if the machine is in q1 and the input is 1, the next state will maybe q1 or maybe q2. So we cannot decide specifically the next state. So that's why it is named so that non-deterministic. We cannot determine the next state. If the automata is in state q0 and the symbol is 0, what will be the next state? From the figure, it is clear that the next state will be either q0 or q1. Thus, some moves of the machine cannot be determined uniquely by the input symbol and the present state. Okay, such machine is called non-deterministic automata. Okay, so a non-deterministic automata also have 5 tuples: q, sigma, delta, q0, f. So what is q? Q is a finite non-empty states. That is, q is the all states set of all states, and it should be finite, so it should be non-empty. Similarly, sigma is the inputs. It is also finite, and it is also non-empty. q0 and f. q0 is the initial state, f is the set of final states. Here, only defined from the deterministic finite automata is the delta. Here, delta may be in the previous deterministic finite automata. What is the case? The combination of q into sigma into q. That means a state and its input combination decide the next state. But here, the next state will be multiple states. So this is the power set of Q. To the power Q is the power set of Q. Here is another example. Okay, what is the case? Here the initial state is Q0 and the final state is Q4. Okay, so in initial state Q0, if we take the input 0. Okay, okay. So there is an example and input string is 0, 1, 0, 0. We have to decide the different states. Okay, 0, 1, 0, 0. So first string is 0. Okay, first string is 0. So this 0, from the state Q0, we decide the next state. So here you can see that the next state may be Q0 or may be Q3. So there is two possibility. So from Q0, there is using 0, there is two case possible, that is 0, Q0 or Q3. The next symbol is 1. Here we can see the next symbol is 1. From Q3, there is no such edge using the 1. So this process terminates here. But from Q0, we can get two different states using the 1. One is Q1 and another is Q0. So we have to take both the cases. So from Q1, if the input is 1, next state will be Q0 and next state will be Q1 as well. And in Q1, the next input character is 0. From Q1, we can see that there is no such edge. So the process will terminate here. But in Q0, there is two possibilities. One is Q0 and another is Q3. So we have to take both the case, Q0 and Q3. Okay. And in Q3, there is a last character 0. If here, if Q3 is the states and 0 into input, from the diagram we can see that the machine moves to the state Q4. So the machine moves to the state Q4. And here in Q0, this is also Q0 and Q3. The same process repeat here. Okay, same process repeat here. So how we get the final states? In this way. In this way, we get the final state. That is Q0, 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 Q3, Q4. Okay. Q0, Q0, Q3, Q4. Okay.